Bright Tuty. Every student matters.
Now, for doing our numericals, let us see how. For applying these equations of motions, right, we need to remember a few things that we have already done. Let us brush up once again. First thing, you must have been knowing that whenever a body or an object starts from rest or a stationary position, right, from rest or from stationary position, we will always take u to be 0. The initial velocity is to be taken as 0. Why? Because the body was at rest. So, when we are comparing this body's velocity, since it was at rest, therefore, we say that initially its velocity was 0. That means its initial velocity is taken to be 0. Got it? Now, in any question, if we are said that whenever a body stops, whenever a body stops, then in that case its final velocity is taken to be 0. The body is stopping means it was initially moving, it was having some initial velocity, but by applying brakes it stopped, or by some opposing force it stopped. And once it stops, that means when we are talking about this particular object, the final velocity is 0, right. Third, quite important thing, whenever the initial velocity is greater than the final velocity. What does it mean? It means that the object was initially moving at a higher speed, and after some time its speed slowed down or reduced. And when it is going to happen? Whenever some opposing force is being placed, or whenever brakes are applied to this particular object, right. So, whenever brakes are applied, whenever initial velocity is greater than final velocity, we will always take acceleration to be negative. Why? Because now the body is retarding, the body is slowing down. Fine. Keeping in view these three things, we will be able to attempt the numericals. Let us see what different kind of numericals we will be facing, alright, and we will attempt those numericals. These three things along with equations of motion and of course the units we need to remember while solving our numericals. This I have told you earlier also. Let us see the first question. First of all, we will see what exactly is given to us in the question. Let us read. A scooter acquires a velocity of 36 kilometers per hour in 10 seconds just after the start. These are the three key ingredients of this particular numerical. I need to relate firstly that this particular scooter was at rest. Just after the start means initially it was in a state of rest, and if it is in a state of rest, then I will take initial velocity represented by u to be 0, because scooter was at rest, right. And in 10 seconds, that means time small t is given out to be 10 seconds. In 10 seconds, it acquired a speed or velocity of 36 kilometers per hour. That means this is the final velocity that is being given to me, which is represented by small v. I need to calculate the acceleration. So, what I need to find is to find the acceleration. Now, the acceleration is given by small a, This is what I need to find. Clear? First thing, we have taken what is given and what is to find. Second thing, as I have already mentioned in my previous lectures, whenever we are doing numericals, please take care of the units. Now, if I see the unit of time, seconds, SI unit, perfectly fine. But when I see this final velocity, I see it is in kilometers per hour. So, first of all, I need to convert it into meters per second. How? It can be written as 36 kilometers per hour means 36 into 1 kilometer divided by 1 hour. Now, I know that in 1 kilometer there are 1000 meters and in 1 hour there are 3600 seconds. Cancelling 00 with these two zeros, 36 with 36, I get the value to be 10 meters per second. Now, this is my final velocity. Right? Now, I need to calculate acceleration. From where I am going to calculate acceleration? From equation of motion. Now, equations of motion, we see there are three equations of motion. One is V is equal to U plus AT. Second is S is equal to UT plus half AT square. Third is V square is equal to U square plus 2AS. Now, whatever is given in these equations, I can relate that from first equation of motion, I can find the value of V provided the other values are given, or U or A or T. These are the four things that I can calculate from the first equation of motion provided the other values are given to me. From the second equation of motion, I can find S, I can find U, I can find A, I can find T, I can't find V. From third, I can find V, I can find U, I can find A or S, I can't find T. So, if I relate, I can calculate U from all the three equations of motions. I can calculate A from all the three equations of motion, right? If I want to calculate V or the final velocity, I need to get dependent on first or third, I can't use the second. If I need to calculate T, similarly first and second equation of motion, not third. If distance, second and third equation of motion, not first, right? So, we need to see what all is given in the question, what all we have to calculate, and then we need to relate which particular equation of motion is best suitable for finding our answer. Right? Applying this concept in our question, we need to calculate acceleration. Now, acceleration I can calculate from all the three equations of motion, but if I relate my question, I am only given with U, V and T. So, if I am trying to calculate it with second or third, I won't be able to do it because S needs to be known, which I am not provided with. So, I will go for first equation of motion, right. Let us see, applying the first equation of motion, we know that V is equal to U plus AT. We know that. No, we don't know. The examiner doesn't know. I need to specify because of first equation of motion. Yeah, simply I can just write, not because of, it is the first equation of motion, right. Alright, putting the values in this particular formula, now I can simply see V I have calculated 10 meter per second, U was given to be 0, A I need to calculate and the time is given to me to be 10 seconds. So, this simply becomes 10 is equal to 10 A or A is equal to 10 coming to the other side, divide by 10, this comes out to be 1 and this is my answer, and whenever I am going to write the answer, I will specify the SI unit too. So, the acceleration of this object is 1 meter per second square. This is my answer. Quite simple, isn't it? Alright, let us take the second question. we are just going to utilize the three equations of motion, the three concepts that we have studied, and the units observation. That's it. Let us see what exactly is given in the next question. First of all, let us see what is given. A moving train is brought to rest. A train was moving and it stops. It is brought to rest within 20 seconds by applying brakes. Find the initial velocity if the retardation due to brakes is 2 meters per second square. Let us see what exactly is given to us. Firstly, a moving train is brought to rest. So, if a moving train is brought to rest, that means final velocity represented by small v, we need to take it 0 because train stops. Brought to rest means it is stopping, right, within 20 seconds. So, time small t is given to me as 20 seconds. The retardation due to brakes, retardation is negative acceleration, right. So, this is the retardation. Retardation is given to be 2 meter per second square, and if it is minus acceleration, so I can write A is minus 2 meters per second square. This minus sign I will bring it here. What exactly I am supposed to find? I am supposed to find the initial velocity of this particular train represented by small u. Now, small u, initial velocity I can find from all the three equations, but we need to see what exactly is given to us. U, we have to calculate v, a and t, no s. So, once again we will be using the first equation of motion, right. We know that v is equal to u plus at. This is through first equation of motion. So, putting the values, we get v is given to be 0, u I need to find out, a is minus 2 meter per second square, and the time which is given to me is 20 seconds. So, this is 20 seconds, right. So, now the initial velocity v is given to be 0, initial velocity I need to find out, fine. So, 2 into 20 is minus 40. So, u comes out taking 40 here, 40 what? Initial velocity. So, the SI unit will be meters per second. So, that means the train was initially moving with an initial velocity of 40 meter per second. If we will retard it at the rate of 2 meters per second square, then after 20 seconds it stops. Got it? Fine? Alright. Let us see the next question. Okay. What does this question say? Let us relate. First of all, again we will see what all is given to us in the question. A body starts to slide over a horizontal surface with an initial velocity of 0.5 seconds. So, given in the question, initial velocity is given to me represented by small u, that is 0.5 meter per second. Due to friction, its velocity decreases at the rate of 0.05 meter per second square. Now, meter per second square, 0.05 meter per second square, meter per second square is the SI unit of acceleration. So, indirectly acceleration is given to me, but what we are being said is velocity is decreasing, that means it is retardation. Now, this is important thing that you need to relate and observe in the question. Got it? So, this is retardation given to us. How much time will it take for the body to stop? If the body is finally stopping, that means its final velocity, that is small v, is given to be 0, and we need to find, or we need to calculate the time taken for the body to stop. We need to calculate t. U, v and a are given to me. So, I will once again apply the first equation of motion. We know that v is equal to u plus at from first equation of motion. Sir, all the questions that are going to come in the exams will be from first equation of motion? Of course not. This is just for your practice as to what different things and how different ways we can calculate the various values using first. Don't worry, you will be getting questions on second as well and third as well. Fine. Just taking examples based on first only. Now putting the values, the final velocity is 0 because the body is stopping. Initial velocity is 0.5 meter per second, plus a is given to be minus 0.05 meter per second square multiply by t. So, this equation becomes 0 is equal to 0.5 minus 0.05 into t. This part I will take on the other side. Taking this part over there, I will get 0.05 into t will be equal to 0.5. Now, keeping t here and just bringing 0.05 here in the denominator side, removing the decimals, multiply by 10 in the denominator, removing the decimal, multiply by 100 in the numerator. 5 and 5 are cancelled out, 0 and 0 are cancelled out. So, the answer is 10, and we are calculating time. So, the answer is 10 seconds. Got it? So, this much will be the time that will be taken by this particular object to stop. Clear? Let us take more examples. So, your wish has been granted, and the next question is not based on first equation of motion. Alright, let us see what exactly is given to us. A racing car has a uniform acceleration of 4 meter per second square. Given to me in the question is acceleration of the car, small a, is 4 meter per second square. What distance will it cover in 10 seconds? The time is given to me, small t is equal to 10 seconds just after the start. If the body is starting, that means initially it was at rest, and if it was initially at rest, that means I am going to take initial velocity to be 0, and what I am supposed to find in the question is the distance travelled by the object. Now, I have to calculate distance, and the knowledge I have, we have three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2s. I will be applying the second equation of motion based on what exactly is given to us in the question. We know that s is equal to ut plus half at square. This is the second equation of motion. Right? I know the value of u, I know the value of a, I know the value of t. Just putting the values, I will get s is equal to u is given to be 0 multiply by t is 10 seconds plus half into a is given to be 4 meter per second square multiply by t is yet again 10 seconds, and I will make the square of it. Right? So, s becomes anything multiplied by 0 is 0. So, 0 plus I will cancel out 2 and 4 with 2. So, I am left with 2 into 10 square is 100. Right? So, now my answer comes out to be 200 what? You have to remember the unit. S is the distance and the unit will be meter. So, it will travel 200 meters before stopping. Got it? Fine? Okay. Let us see another question. Alright. A scooter moving at a speed of 10 meter per second. Initially, the scooter is moving at this particular speed. So, given to me in the question is the initial speed of or the initial velocity of the scooter represented by small u to be 10 meters per second. And this scooter is stopped. If the scooter is stopped, that means I am given the final velocity v is equal to 0 as scooter stops. By applying brakes which produce uniform acceleration of minus 0.5 meter per second square, minus sign in itself states that it is retardation. So, the retardation or negative acceleration is given to us. This is minus a, but I am not taking minus sign here. Because it is given to me, minus sign is given to me in the value itself. So, acceleration is negative. That means it is retardation, right? How much distance will be covered by the scooter before it stops? Once again, I need to calculate or to find the distance travelled by this particular scooter. I need to calculate the value of small s. Now, u, v and a, I will be applying the third equation of motion. We know that v square is equal to u square plus 2as. This is our third equation of motion. Putting the values, I know all the values are given to me in the question. The value of final velocity is 0, initial was 10, acceleration is minus 0.5. So, putting the values, final velocity is 0, initial velocity was 10 whole square plus 2 into acceleration is minus 0.5 multiplied by s as it is. So, this comes out to be 0 is equal to 100 plus and minus is minus, removing the decimal, and 10, 2 1 the and 2 5 the, 5 and 5 are cancelled out. I am just remained with minus s. Taking s over here, s is equal to 100. Again the SI unit, that is meters. This is my answer. Got it? This will be the distance travelled by this scooter before it stops. Got it? Quite easy, right? Simply you need to see the units and the equations of motion, that's it. Next question. A car travelling at 20 kilometers per hour. What is given to me? Initial velocity. Why? Because the car is actually travelling with this speed at initial level. It is 20 kilometers per hour. I know of course that I need to convert it. So, doing it here only. 20 kilometers can be written as 20 into 1 kilometer per hour is 1 hour. So, this comes out to be 20 into, rather than writing 1 kilometer, I can write 1000 meters divided by 1 hour is equal to 3600 seconds. Cancelling out the zeros, 2 1 the and 18 the, cancelling it with 50 by 9. Let us take for the timing, let us take till here only 50 meters per second. This is the initial velocity. Then the final velocity, because the car speeds up to 60 kilometers per hour. The final velocity is given to be 60 kilometers per hour. Again converting it, 60 multiplied by 1 kilometer divided by 1 hour, which can be written as 60 multiply by 1000 meters divided by 3600 seconds. Cancelling the zeros, I will get 6 1 and 6 6 the, I will get 3 and 50, I will get 50 by 3 meter per second. This is the final velocity and this is in 6 seconds. So, the time is given to me to be 6 seconds. What I need to calculate is acceleration. So, to find or to calculate is the acceleration or small a. Which formula we will apply? First equation of motion. We know that V is equal to U plus AT because this is our first equation of motion. Now, putting all the values, the final velocity is 50 by 3, initial velocity is 50 by 9, t is 6 seconds. By putting the values, we will just calculate the value of acceleration. Let us see how. Final velocity was 50 by 3 meter per second, initial velocity was 50 by 9 meter per second plus a into time was 6 seconds, right. So, this comes out to be 50 by 3 is equal to 50 by 9 plus 6a. Taking this on the other side, I will find this equation to be 50 by 3 minus 50 by 9 is equal to 6a. Taking the LCM here, this will be 9, right. This will be 150 minus 50 is equal to 6a or a 6a is equal to 100 by 9. Got it? Simply cross multiplying or taking 6 over here, I will get a is equal to 100 by 9 into 6, which comes out to be 53. A is equal to 50 by 27. It is not being cut further or reduced to lower values. So, the acceleration is 50 by 27, which comes out to be approximately 1.9 meter per second square, right. If you will divide it up to 2 decimal places, it will be probably 1.88 or 1.89 meter per second square. Rounding it off, I can write it to be 1.9 meter per second square up to 1 decimal place. Got it? So, this is the acceleration of this particular car. Got it? Right? Hope you have understood it. Please try to practice and try to read it. Thank you.